Hi, Rob. Last year, Energy Vault redesigned its core product. What changes were introduced and why?
Main changes introduced with our new what's called EVX. So that's our new system platform for gravity that's being built over 3 continents right now. And the two main changes, one was a form factor change where we went with a simplified structure, like any building, with a fixed frame and a foundation, to also have something that you could clad and cover, just like any building. So essentially, we simplified that to enable our ability to build these systems out also in a very modular way. So that was a simplification, but the same software, the same composite blocks, and we use soil and other waste materials, so we do not use concrete for that. And the same fundamental lifting and lowering and system of those bricks. The second change we made was related to having something where you could decouple energy and power, meaning customers could define how much power they wanted to discharge and over what duration. So almost like a lithium battery system where you can decide, I want to do 50 megawatts over 4 hours for a 200 megawatt hour system, or I want to do 100 megawatts of power over 10 hours. So for a full gigawatt hour, which is what gravity really in our technology utility scale is designed to do, large hundreds of megawatt hours or multi-gigawatt hours. So those were the two main changes.
So, can you share some tech specs with us?
Our systems essentially start at about 50 megawatt hour. That's basically the minimum. So we're large utility scale. We can define the power anywhere from 5 megawatt, up to hundreds of megawatts in terms of power discharge. And we can do that. Typically, we start at about 4 hours with gravity at the minimum for economics, but we're going to be optimal in the 6, 8, up to 12-hour range. And that's going to be, I think, more ideal for the longer duration system. The round trip efficiency with EVX is going to be between 80 to 85%. We already proved out with our initial system at 75% plus, which was the highest for any mechanical system in the world. With the simplification we did with EVX, we know we're going to be in the 80 to 85% range, which again starts to approximate what other electro chemistries are, like lithium-ion batteries. For technical life, that's again one of the benefits with our projects is we look at 30 plus years. I mean, theoretically, it could be 40 or 50 years because it's a simplified structure in a building. So we're going to focus on, longer duration, utility, large scale, hundreds of megawatt hours at a minimum, up to multi-gigawatt hours, and building these projects out in the longer duration market.
But your system is not so easy to build, right?
But ideally for us, we would build projects typically at a minimum of about 100 megawatt hour and 8 hours of duration. So you can think about 10 to 15 megawatts. But really for us, ideally, we're going to be building projects that are going to be in the 300 to 500 megawatt hour, and typically in the 8 to 12 hours type of storage range, and that gets very optimal from an economic perspective. And that's going to be toward applications to make green hydrogen, for example, where you need long duration, or to power facilities that need powered overnight, for example, like desalination plants or any 24-hour manufacturing facility requirement, or longer duration needs that utilities may even have now.
Can your system compete with lithium-ion batteries in terms of levelized cost of storage?
On a levelized cost on longer term projects, so when you get to projects that have a life of at least 15 to 20 years, and when you're focused on longer duration, the levelized cost over time gets very, very attractive and will be much better than lithium ion. And that's primarily for a few factors. Number one, there's no degradation of our storage technology. So lithium-ion batteries require what's called augmentation CapEx, or capital expenditures, to replace depleted cells. In addition, our operating expense is lower. We can operate at any ambient temperature environment, and our only operating expense are maintenance of the multi-megawatt motors and some of the lifting systems. So as a result of that, when you add up the lack of augmentation CapEx and the lower operating expense and our longer life of the technical life of the project, we do much better on a levelized cost than lithium ion.
And in hard figures, that is?
It's going to range anywhere, depending on power and duration, anywhere from 3 to 4 cents up to 7 to 8 cents a kilowatt hour.
Our time is up. Thank you, Rob.